Hi again! I hope you're enjoying your flight in outer space. Speaking of space flights, I want to show you a simple way to model a space traveling system without having to refine SD. Recall that values are states of an attribute. In this SD, we see the three values of the attribute location of spacecraft: on Earth, in atmosphere, and in space. We want to show how space traveling transforms the location of spacecraft by going through these values. Space traveling takes us from Earth to space, but it should also take us back to Earth. As much as we love space travels, we always want to come back home at the end of the journey. An input-output or in-out link pair is a pair of procedural links that indicate change of state or value. Let us add in-out link pairs between space traveling and the values of location. Great! But we still have a problem similar to the one we had before. The way we connected the links leaves the model underspecified, because there is more than one link going out of the space traveling process, so we are not sure which one to follow. Suppose we start following the input link from the value on Earth to space traveling. Now the corresponding output link of this in-out link pair that we should follow is not clear. Does space traveling change location from on Earth to in atmosphere or to in space? We know that launching takes us from Earth first into the atmosphere and only then to space. But how do we specify this in the model? To resolve this ambiguity, we add the path label launch along the input link from on Earth and the same path label along the output link to in atmosphere. Next, since our location is in atmosphere, the only way to continue is along the input link from in atmosphere back to space traveling and from there to in space. From in space we return to on Earth, again via the space traveling process. To specify these transitions unambiguously, we add the path labels flight and re-entry. Following path flight, space traveling changes location of launch complex from in atmosphere to in space. Following path re-entry, space traveling changes location of launch complex from in space to on Earth. Going to space requires fuel, which provides the kinetic energy that the spacecraft needs to escape the Earth's gravity. To specify this, we add the path label launch also to the consumption link from fuel to space traveling. Great! As you can see, the same process, space traveling, changes values of location as we wanted it according to the path labels. In addition, we add the path label launch from fuel, since the fuel is consumed during launch. The triple usage of the launch path label demonstrates that we can use path labels to specify path of execution that contain more than two links, and this need not be necessarily performed in sequence. One or more path labels which determine a specific set of procedural links that must be followed define a scenario. The usefulness of paths grow with the system's complexity. In complex systems, multiple various scenarios can develop depending on decisions, events, and probabilities. Here comes Hopka to summarize things for us.
Execution path. A path followed by a specific execution of the model.
Enough for today. Continue your journey safely. I look forward to seeing you again soon.